Okay, welcome to this lesson on a introduction to expressions, algebraic expressions. One more time. So, in the topic of algebraic expressions, we actually have a few things. I think what you learned last year is probably much on linear expressions, in fact, and you learn a little bit on linear expressions such as expansion and so on and so forth. So, just as a very quick recap, what are linear expressions? Linear expressions, okay, maybe I'll just write it here. They are expressions up to they have terms, right? Have terms, okay, with variables in each term with a power of up to 1. Okay, what does this mean? Some examples of this would be, for example, what we know of as 8y minus 7. This is a linear expression because the variable y, okay, has an invisible power, okay, of 1. Okay, so this is a example of it. Give you a few more examples. It could have let's say negative 4x plus 3y. Okay, this is also a linear expression, but this is in two variables. Okay, and all the terms have a power of up to 1. So what is linear? What could be linear is also a constant term, one with a constant term, let's say 6. Okay, yes, this is a number, but if you put it in expression, it could be an expression as well. So this is what linear expressions actually mean. So I'm just going to draw a box such that you can write this down beside your notes. Now with that, let's try to dissect what are linear from this pool of algebraic expressions that we have. The very first one that we have is 7 minus 4x. Okay, this is linear because number one, the term x has a power of 1 and there's no other things that are more than that. So that's why it's linear. So we've covered this, and then next we have x squared plus 1. This would be considered non-linear. Okay, because this term has a power of 2, so that's why it's non-linear. And here we have 2 minus x minus divided by 9. As long as your algebraic term is in the numerator, that's great. Okay, so in this case, this is also considered linear because you can in fact write this expression into something like that. So I'm going to write it down here. This can be expressed in 2 over 9 minus 1 over 9 times x. So in this case, this is still linear. Okay, next we have 4x squared minus y plus 8. This is actually non-linear just because of one term, right? The 4x squared term. So the 4x squared term that makes it non-linear. The number 4 is linear as what we said earlier. Okay, now we have this unique term here, 2xy minus 3x plus 1. So we have the 3x term there, which should make it linear. We have the 7 term there, but we have this term 2xy. So this term has a variable of xy. Now before I can begin on whether is this considered linear or non-linear, let's start with x squared. Okay, so x squared is definitely non-linear. It's a term that makes it non-linear, and this is simply x times x. Okay, the reason why it is not linear is because you have a variable multiplied by another variable, so that makes it non-linear. And in this case of xy, it is x times y. So yes, we have each of the variable has a power of 1. But when you multiply two variables of power 1 each, that has an overall power. Okay, so the overall power of this, that means you just add the powers together, overall power of this is 2. So this would make it non-linear, in fact, because it has an overall power of 2. We're using the same idea as what x squared means. X squared just means x times x, which makes it non-linear. So x times y also is non-linear because we have an overall power of 2. I can give you some examples of that. So for example, if I have x squared y times y, so this variable here is actually x times y, and in this case this is also non-linear because this has an overall power of 3, because it's x squared is 1 plus 1 plus 1, right? So 2 plus 1. So in this case 2xy minus 3x plus 7 is non-linear as well. Okay, subsequently we have x squared minus 5x plus 6. This is also non-linear. And we have AD, AC, BD, BC. Each of these terms, okay, we regard A and D as variables now. So these are all non-linear as well. And next we have this. So we can actually quickly sort all of these out, okay, to realize what is linear and what is non-linear. Okay, so if it's just a term alone with a single variable with a power of 1, that's definitely linear. Anything else, it's non-linear. Okay, you may want to pause this video to kind of like see this if you need to. Okay, so in this part of this topic, okay, we would like to talk about some unique expressions in the non-linear branch. So we are going to talk about one very important kind of expressions, and we call them the quadratic expressions. So I'll just highlight these two special ones. So what are these two special expressions called? Okay, these are called quadratic expressions in one variable x. Okay, the keyword here is really simply in one variable. Okay, it cannot have two variables, x, y. You cannot have three variables. You can only have x. Whether it's x squared or x, is still in one variable x. So a quadratic expression in one variable x is of the form. So all quadratic expressions come in the form ax squared plus bx plus c. Now, just to mention, we regard a, b, and c as constants. Okay, a, b, and c are constants. Constants would just means they are just numbers. Can be any real numbers. Okay, we are not regarding them as variables. Okay, we are regarding them as constants, numbers. Alright, and especially we have a case where a is not equals to 0. Why a is not equal to 0? Because if a is equals to 0, then the expression would become 0 times x squared plus bx plus c. Right? 0 times anything just becomes 0, right? So this just gives me bx plus c. So bx plus c is actually something we know already. These are considered linear. So we cannot have, we cannot have a to be equals to 0. A cannot be equals to 0. Okay? So one very simple example of quadratic expressions, for example, from just now we have x squared minus 5x plus 6. Okay, as long as, in this case we can identify a is equals to 1. Let's compare with this over here. Okay, we can see that a is equals to 1, b is equals to -5, and c is equals to 6. Okay, so let's make some comparison with the general form. We can also have different types of quadratic expressions. -x squared plus 2x minus 3. Alright, this would actually mean that a is equals to -1, b equals to 2, and c is equals to -3. Okay, so this follows the the rule that we have for quadratic expressions. we could also have a very special one. We saw just now we had x squared plus 1. I was like, oh no, is this considered quadratic because we don't have the x term, we only have an x squared term. Okay, so let me just rewrite this. Could this actually be x squared plus 0 times x? Okay, the dot represents 0. Okay, plus 1. And in this case, in this case, a is equals to 1, b is equals to 0, and c equals to 1. We can have that too. Okay, because our only condition here is that a must not be equals to 0. It cannot be equals to 0. That's all. Alright, so but b and c you can be equals to 0. Okay, we could also have 16x squared plus 4x, and this is still quadratic. Okay, we call this quadratic, where a equals to 16, b equals to 4, and c is equals to 0. Right, there's an invisible plus 0 behind. Right, just that we can't see them yet. Okay, next we also could have, I think, what else do we have? We can have fractional quadratic expressions, for example. 1 over 9x squared plus x over 16 plus 4. Okay, so from here we can deduce that a is equals to 1 over 9, b equals to 1 over 16, and c equals to 4. Okay, it's totally possible to have this. So these 4 examples here are examples of different kind of quadratic expressions, okay, written in this form. So it's pretty important to be able to identify quadratic expressions. And yeah, alright, so that's the introduction of quadratic expressions. Thank you.